When a golf player hits a golf ball, a baseball player hits a baseball, and a tennis player hits a tennis ball, then you can notice that here the motion of these balls are of the same kind, and it is called a projectile motion. So let's discuss about the projectile motion in detail. When you throw an object at an angle, then the motion of that object is called projectile motion. In this clip, these persons are enjoying physics. You can see that two persons are applying some oil on this curved ramp, and one person is going to take this ride. Here he goes, and finally he falls in this water tank. The person who designed this activity definitely had complete knowledge about the projectile motion. Otherwise, this game is quite dangerous for them. So let's study about the motion of this person. Before going to start knowing about the motion of this person, first let's choose the coordinate axes like this. And also assume that the whole arrangement is inside an empty room. When you flash the light from the above, then the shadow of the person falls in the XY plane, and you can observe that the velocity of the shadow is constant. When you flash the light from the right side, then the shadow of the person falls in the YZ plane, and you can observe that the velocity of the shadow is continuously changing. But why these shadows behave differently? Because in this case there is only one force acting on the person, and this is the gravitational force that is constant and acting along the minus z axis. So the acceleration of the person along the x-axis is ax equal to 0, and his acceleration along the z-axis is az equal to minus g, which is equal to minus 9.8 meter per second square. Here g is the acceleration due to gravity. Let the person leave the ramp at time t equal to 0 with the velocity v0 along a direction which makes an angle theta with the positive x-axis. Also assume that the total time taken by the person to reach the water tank is t, the range is r, and the maximum height reached by the person is h. At x equal to 0 and t equal to 0, the x component of his velocity is v0 cos theta, and the z component of his velocity is v0 sin theta. At x equal to r by 2, t equal to t by 2, and z equal to h, that is at the position when the x coordinate is half of the range, the time is the half of the time of flight, and the z coordinate is the maximum height, the x component of his velocity is again v0 cos theta, and the z component of his velocity is 0. And finally, at x equal to r, t equal to t, and z is equal to 0, the x component of his velocity is v0 cos theta, and the z component of his velocity is v0 sin theta, with its direction along the minus z axis. Since in this example the acceleration is constant, so we can apply the equations of kinematics to find the equation of the trajectory, the time of flight, the maximum height, and the range of the projectile motion. Here we have the set of 4 equations of kinematics. At any time t, if you consider the motion of the person only along the z-axis, then by using the equation 3, the z coordinate of the person is given by z equal to v0 zt plus half az t square, which is equal to v0 sin theta t plus half minus g t square, and finally the equation will be z equal to v0 sin theta t minus half g t square. Let this equation is equation number 5. If you consider the motion of the person only along the x-axis, then by using the equation 3, the x coordinate of the person is given by x equal to v0 xt plus half axt square, which is equal to v0 cos theta t plus half times 0 times t square, and finally the equation will be x equal to v0 cos theta t. This is equation number 6. If you plug the value of t from equation 6 into equation 5, then the equation 5 becomes z equal to v0 sin theta times x by v0 cos theta minus half g times x by v0 cos theta whole square. And finally the equation becomes z equal to x tan theta minus gx square by 2 v0 square cos square theta. This is the equation of the trajectory of the projectile motion of this person. Considering the motion of the person along the z-axis during the time t equal to 0 to t equal to t by 2. We have the initial velocity is v0 z equal to v0 sin theta. The final velocity is vz equal to 0. The acceleration is az equal to minus g. The displacement is delta sz equal to h, and the time interval is t equal to t by 2. By using equation 1, we can write Vz equal to V naught z plus Az t, that is 0 equal to V naught sine theta minus z times t by 2. And from here you can get t equal to 2 V naught sine theta by g. This is the formula for the time of flight. By using equation 4, you can write Vz square is equal to V naught z square plus 2Az delta Sz, that is 0 square equal to V naught sine theta whole square plus 2 times minus z times h. And finally, you can get h equal to V naught square sine square theta by 2g. This is the formula for the maximum height. If you consider the motion of the person along the x-axis during the time t equal to 0 to t equal to t, we have the initial velocity is v naught x equal to v naught cos theta, the acceleration is ax equal to 0, the displacement is delta sx equal to r, and the time interval is t equal to t. By using equation 3, you can write delta sx equal to v naught xt plus half ax t square. That is r equal to v naught cos theta t plus half times 0 times t square, which is equal to V naught cos theta times 2 V naught sin theta by g, which is equal to V naught square times 2 sin theta cos theta by g. Since 2 sin theta cos theta equal to sin 2 theta, so r equal to V naught square sin 2 theta by g. This is the formula for the range. These formulas are valid only for the case when the point at which the projectile is launched and the point where it hits the ground are at the same horizontal level. For all other cases, these formulas are not valid. So you must know how to use the equations of kinematics, and by doing that you can solve the problems of any type of projectile motion. Here is a question for you. The question is, a projectile is thrown from the ground with an initial velocity of 20 meters per second at an angle of 30 degrees above the horizontal. Find the maximum height, the time required to reach its maximum height, its velocity at the top of the trajectory, the range of the projectile, and the total time of the flight. So let's move to the solution of this question. Here you have initial velocity of the projectile, which is v naught equal to 20 meters per second. Angle of the projectile, which is theta equal to 30 degree. In part A, you have to find the maximum height of the projectile. So use the formula for the maximum height and find the answer for this part. In part B, you have to find the time required to reach its maximum height. You know that the time required to reach its maximum height is equal to the half of its time of flight, that is t equal to t by 2. So use the formula for the time of flight and find the answer for this part. In part C, the velocity at the top of the trajectory will be v equal to v naught cos theta. So plug the values and find the result. In part D, you have to find the range. So use the formula for the range and find the answer for this part. And finally, in part E, you have to find the total time of flight. So use the formula for the time of flight and find the answer for this part. I hope you enjoyed this video. If you have any queries about this topic, then feel free to write in the comment box. If you like this video, then subscribe to this channel and press the bell icon. Thank you so much.